Textiles are a part of everyone's daily life. In this video, we will explain how materials and energies are flowing within the processes of the textile industry. We will also explore opportunities for improvements within the cleaner production principles. First, the flowchart presents a textile industry producing synthetic textiles. The inputs are synthetic fibers, energy, water, and chemicals. Synthetic fibers are, for example, polyester and nylon. Energy is used for heating and electricity. Water is used in large amounts in many of the processes. Many heavy metals and toxic chemicals are used, mostly from using catalytic agents and petrochemicals. The outputs are textile products together with waste and emissions. Waste from the processes are textile byproducts, wastewater, heat, and solid waste. The products are, for instance, textiles for apparel, interior, and furniture. The emissions from the processes are, among others, nitrous oxide, carbon dioxide, and sulfur dioxide. The first step of the process is the yarn formation, where the fibers are texturized. The following step is the fabric formation, where weaving and knitting are included. After this step, the fibers are going through the wet processes: preparation, dyeing, printing, and finishing. During the wet processes, a lot of toxic substances and water are used. Salt and chemicals are mixed in the water. The last part of the textile process is fabrication, where the textiles are cut and sewed. The material inputs are divided into fibers, water, and chemicals. The orange arrow represents the flow of the fibers. Most of it comes out as textiles, but 11% are lost in the waste process. The blue arrows represent the water flows, where the bottom one shows that 56% of the water can be recycled. The purple arrow shows the chemical flows, where 47% of the chemicals will end up in the textiles. Here, the diagram shows how the energy is distributed in different processes. The processes with the most environmental impacts are when using stabilizing agents, dyeing, and finishing. These processes contain heavy metals and chemicals like sodium hydroxide, mineral oil, sulfur dioxide, and formaldehyde. Downstream, these chemicals and heavy metals are toxic to both the environment and to humans. Some also cause eutrophication. The synthetic fibers are made either from chemical solutions or from petrochemicals, which is the source of many environmental issues upstream, like oil spill and pollution. Now, let's introduce some possible solutions for creating a more sustainable textile industry. We will go through the methods very briefly. There are many possibilities to recycle wastewater in the textile industry. It's easier to reuse the water from rinsing steps later in the process since less hazardous substances remain. When there are higher concentrations of chemicals, proper cleaning methods are needed. One applicable method is reverse osmosis, which can be used in the membrane bioreactor. Other recycling methods are dye bath reuse and recycling of unexhausted dye stuff and additives. In cooling processes, a lot of heat is wasted. This heat can be recycled and used to heat the water needed in the rinsing and dyeing processes. Over 60% of energy can be saved by recycling heat in this process. This can be managed by recycling of condensate in the dyeing process or a counterflow heat exchanger. Better environmental performance can be set up by implementing robust raw material quality control. On an operational level, the housekeeping can be improved by creating a robust training for employees and maintenance plan. This covers daily inspections and pre-screening of raw material. Moreover, the process can be improved by implementing a closed loop, such as countercurrent washing. The textile industry may also benefit from optimizing the process conditions, for example by chemical substitution, changed temperatures, or time efficiency. Other cleaner production modifications that can benefit the textile industry are, for example, combining scouring and bleaching processes, finding substitutions for chemicals, and modification of the existing equipment. That was all from us. Thanks for your attention.